Few episodes in the history of journalism showcase the power of the press as well as the media whirlwind that erupted in the United States in the late 1940s. One summer day in 1947, Kenneth Arnold, an experienced pilot, went to an Oregon newspaper to report a strange sighting he had made. He claimed to have spotted a squadron of ships between the mountains, 9 boomerang-shaped objects that far exceeded the maximum speed of any airplane. Suspecting it might be a Soviet espionage mission, with the shadows of the Cold War spreading across the world, he hoped they could give voice to his account. However, eager for a story that would give them powerful repercussions, the journalist decided to embellish his story. If they insinuated that the crafts the pilot had seen were not of this world, if they left open the possibility that the sighting was the first contact with an extraterrestrial civilization, visitors from space, then they would have the event of the year. Misinterpreting the pilot's description, believing that the movement he had detailed was actually its shape, although such a thing was never mentioned, the newspaper wrote an article about something they had dubbed flying saucers. With that misunderstanding, the concept had just been born, and the media storm was moments away from unleashing. The impact of the report was immediate. Dozens of American newspapers echoed the news, and supposed sightings of saucer-shaped ships skyrocketed. Probably all alien races had to redesign their interplanetary ships to adapt to an Oregon journalist's mistake. Because despite that error, the flying saucer fever had erupted. In less than a week, over 800 alleged cases were reported, with people sending photographs of encounters with saucers that until 7 days ago, no one had ever seen. A collective hysteria over contact with beings from other worlds that divided society between those who were convinced that something was hidden among the clouds, and those who considered those accounts mere fantasies. But however it was, the flying saucer fever inspired a question that would lead us to venture to the limits of space and time. In the midst of an increasingly calm hysteria over star visitors, in the summer of 1950, the New Yorker magazine published a comic strip accusing green little men of being responsible for a curious wave of trash and thefts occurring in New York City. Coincidentally, a copy of the magazine reached the Los Alamos National Laboratory into the hands of Italian physicist Enrico Fermi, who at that time was working at the Atomic Energy Commission. Following the comic strip, several scientists had a relaxed conversation during breakfast. Reports of what would soon be dubbed as UFOs and the feasibility of traveling faster than light sparked a debate about the possibility of being truly visited by an extraterrestrial civilization. Because despite the media circus that had formed around it, discovering that we are not alone in the universe would be the most important and philosophically significant discovery in human history. In an attempt to show that it would be impossible to develop technology that would allow us to exceed the maximum speed limit in the universe, something essential for interstellar travel to be feasible, Fermi said that if it were feasible, any advanced civilization would have had time to reach Earth. If that technology were attainable and the cosmos is inhabited by many other alien civilizations, those little green men would have already visited us. An opinion condensed into a thoughtful question. Where is everybody? A question that, unaware of it, was going to ignite over 70 years of debate. To ask ourselves what role we play in the eternal forest of the universe.
En ese momento, la crítica de Fermi quedó como una simple anécdota. Al fin y al cabo, ser visitados era la única forma de saber si ahí fuera había alguien más. Si no venían hasta nosotros, íbamos a seguir a ciegas, a no ser que fuéramos capaces de ver lo invisible. Mensajes ocultos en la niebla del espacio.
With the birth of radio astronomy in the 1930s inspecting the sky in the radio wave spectrum, a new cosmos was revealed to us. Everything beyond visible light, previously invisible, became within our reach. radio signals from the depths of space and time led to the discovery of celestial bodies that we would never have known otherwise. But it wasn't until the late 1950s that we expanded our horizons to something beyond nature. In an article published in Nature in September 1959, Giuseppe Cocconi and Philip Morrison suggested that radio telescopes had reached sufficient sensitivity to detect potential alien transmissions, to capture communications from a hypothetical civilization. Unlike other waves in the electromagnetic spectrum, radio waves travel more freely, being very little affected by interstellar dust and gas. It was reasonable to think that any civilization capable of communicating would be using radio signals to do so. Therefore, if we wanted to answer the eternal question of whether we are alone in the universe or not, we could not wait for another form of life to establish contact with us. We had to search for the echoes of their existence. Under this pretext, and with more justified hopes than ever, in 1960, the young American astronomer Frank Drake developed a pioneering experiment in the search for extraterrestrial signals. As part of the so-called Project Ozma, he used the 26-meter Green Bank radio telescope to inspect two nearby stars, Tau Ceti and Epsilon Eridani, in hopes of detecting possible radio transmissions. As expected, given the small scale of the project and the limited resources available, Project Ozma concluded a few months later, in July 1960. No extraterrestrial signals were detected, no indication of the existence of a civilization emitting radio waves accidentally or intentionally. But far from being a failure, Drake captured the attention of the entire community, which after so long saw a glimmer of hope. Many felt that it was only a matter of time and effort before we stumbled upon the discovery that would forever change our view of life and our place in the universe.
Por primera vez en la historia, Drake había escuchado la oscuridad, buscando susurros en medio de las tinieblas, y viendo que los seguidores estaban creciendo, que cada vez más gente quería sumarse a esa ambición, organizó un encuentro para establecer las bases del proyecto SETI, un acrónimo para el inglés, Búsqueda de Inteligencia Extraterrestre.
Ten scientists attended the meeting held at Green Bank in November 1961. The participants, including a young Carl Sagan, paved the way for the development of an international project focused on using various radio telescopes around the world to analyze signals that could be indicative of the existence of intelligent extraterrestrial life. The foundations of what would later be known as SETI, the Search for Extraterrestrial Intelligence, were established at that gathering. A meeting at which Drake, in support of what they were building, presented an equation that he hoped would show that their hopes had a basis. He had developed a formula to estimate the current number of communicative civilizations in the galaxy, expressed in the equation as an n, which is the result of a series of parameters multiplied together to reach that coveted figure. Specifically, it involves the current rate of formation of new stars, multiplied by the fraction of stars with planetary systems around them, multiplied by the quotient of planets meeting the necessary habitability conditions, multiplied by the fraction of those worlds where life germinates, multiplied by the proportion in which that life evolves into intelligent beings, multiplied by the fraction of those who use their intelligence to develop and transmit communications, multiplied finally by the average lifespan of those civilizations. The so-called Drake equation sought only to simplify the parameters that scientists should consider when international efforts began in the search for intelligent life. It was merely a tool to guide the meeting, a simple approximation rather than a serious attempt to arrive at a precise result given so many variables that were impossible to decipher. We can know the rate of star formation, the first parameter of the equation. By inspecting stellar nurseries, nebulae in whose depths the gods of light of the universe emerge, we have discovered that the current birth rate of stars in our galaxy is about 7 per year. Likewise, all observations of stellar systems have led us to deduce that planets are a natural consequence of the birth of a star. That practically all gods of light have offspring navigating their vicinity, making the second variable of the equation also known, and that this quotient of stars with worlds around them is very close to 1. But beyond this, a devastating uncertainty reigns in the equation.
Superados los parámetros astronómicos, los únicos que podemos conocer, nos sumergimos en un terreno sin cartografiar. Con cada siguiente variable, nuestra ignorancia aumenta. Todas las que tienen que ver con la astrobiología, las probabilidades de que en un mundo inerte emerge la vida inteligente, están rodeadas de incertidumbre. Pero entrando en los sociológicos, ni siquiera podemos definir algo con sentido. Solo conjeturar, especular y adivinar.
Nevertheless, and against what Drake himself believed, when his creation became famous enough to cross the media frontier, the equation began to be perverted by supposed scientists who tried to pass divination off as evidence. Many people began to play with the equation, assigning values to astrobiological and sociological parameters at will, to reach a result that, due to the inherent uncertainty of the formula, could not describe any reality. Nevertheless, the media echoed the publications, turning Drake's equation into one of the most famous formulas in history, and selling the idea that there could be between 1,000 and 100 million detectable intelligent civilizations in the galaxy, when in reality the only certainty is that we don't know. But despite this pseudoscientific exploitation, the impact of Drake's equation allowed the entire world to become aware of the efforts being made from the United States to achieve the discovery of life beyond Earth. And such was the impact that in the midst of the Cold War, a group of Soviet astronomers joined them as part of the SETI project. The ambition to fulfill that dream had broken all boundaries between two countries, leading a contest between two ways of understanding the world. In this context, astrophysicist Nikolai Kardashev became the visible face of the project in the Soviet bloc. In 1964, 3 years after the formulation of Drake's equation, the Russian scientist organized a conference at the Byurakan Observatory in Armenia. Kardashev brought together the great eminences of the field of radio astronomy to, in his own words, find viable techniques for the detection of extraterrestrial signals and solve the linguistic problems that could arise from communication with a hypothetical civilization, more advanced than human. He had set out to define what we needed to search for in the darkness.
El físico soviético creía que si no dejábamos de considerar que las civilizaciones extraterrestres serían iguales a la nuestra, el fracaso estaba garantizado. Unos cientos o miles de años, por no hablar de lo que supondría unos millones de años de ventaja, haría que tuvieran una tecnología muy distinta a la nuestra. Si queríamos encontrar algo, primero debíamos saber qué estábamos buscando.
Starting from this premise, Kardashev developed a method to categorize civilizations, a way to classify any civilization in the universe according to a single parameter, their energy usage. They would all be very different from one another, but each and every one of them, in one way or another, would have to consume energy to survive, and above all, to fulfill their ambitions. At that conference, the scientist presented to the world what he himself had baptized as the Kardashev scale, measuring the degree of technological evolution of a civilization based on the amount of energy it is capable of utilizing from its environment to classify them into 3 categories. Firstly, a Type 1 civilization, which we ourselves are transitioning towards, is one that has managed to master its world, to control and use all available energy on its home planet at will, an absolute power over its resources, ecosystems, and climate. With this energy dominance, if they haven't turned their world into an uninhabitable planet and perished due to their growth ambitions, beings will cast their gaze to the skies. Their planet will have become too small for them, and the path to a new class of civilization will have begun. Because secondly, on the scale, a Type 2 civilization will be one capable of mastering its parent star, to control its sun, harvesting all the energy from the god of light that gave them life through a megastructure beyond our dreams. In that ambition to take the next evolutionary step, the civilization will begin to sacrifice its sibling worlds, to destroy other planets and bodies in its system, especially asteroids, rich in minerals and easier to manipulate due to their low gravity. They would turn the entire empire of their star into a colossal mine, with the exclusive purpose of raising the most colossal structure in the cosmos, an evolutionary leap comparable to the discovery of fire, the construction of a swarm of solar collectors that would form a kind of sarcophagus around the sun, about 30 quadrillion panels constituting what would be baptized as a Dyson sphere. With such a creation, the civilization would be controlling all the energy of a star, even being able to raise it around a black hole, a technological feat, to keep a monster of darkness inside a sarcophagus to achieve virtually infinite energy. In one way or another, they will have become a Type 2 civilization, and with the power of the gods in the palm of their hand, they will have broken all the boundaries of space and time. Because thirdly and lastly, a Type 3 civilization will be one that will have mastered an entire galaxy. That will have harvested the energy of each and every star in its island of light. With the energy obtained from the Dyson sphere, interstellar travel will become feasible. They will only need time and resources to conquer their entire galaxy. Even assuming they continue to use archaic chemical propulsion like humans do today, it would only take about 300 million years to colonize every last one of the 100 billion stars that on average inhabit a galaxy. And although 300 million years may seem like an eternity, on a cosmic scale, it is nothing. With its 13 billion years, the Milky Way could have been conquered more than 40 times over. A single civilization as advanced as this would be enough to fill an entire galaxy. And if they have technologies that for us are purely hypothetical, they could achieve that conquest in just 1 million years. With galactic dominance, they would have reached the last level of the scale, a point from which motivations would transcend our poor human knowledge, virtuosity and power unfathomable to us, the pinnacle of biological evolution.
Hasta ese momento, con las ondas de radio, siempre habíamos buscado ecos de una civilización que, como la nuestra, estaba en camino de convertirse en una de tipo 1. Con su teorización quiso mostrar que los esfuerzos tenían que centrarse en captar las señales de una tecnología propia de una civilización de tipo 2 o de tipo 3. La escala de Kardashev, de algún modo, quería guiarnos en ese camino entre la oscuridad.
When news of the Soviet conference spread around the world and the scientists involved in SETI discovered the foundations of the Kardashev scale, hopes of finding traces of intelligent life grew stronger than ever. So much so that NASA itself funded some of the early projects, marking the beginning of over 6 decades of search. Since the 1960s with SETI and more recently with Breakthrough Listen, a project initiated in January 2016 with a funding of $100 million representing the most comprehensive search for intelligent life, we have scanned millions of star systems in the Milky Way and hundreds of galaxies. The most obvious experiments have been the search for radio signals emitted by extraterrestrial communication systems. But following the fundamentals of the Kardashev scale, there have been attempts to find even stranger traces. Efforts to capture optical signals, brief laser pulses that cannot be generated by nature but by artificial mechanisms of an advanced civilization. Similarly, there has been an aspiration to capture the echoes of a possible Dyson sphere in a system of our galaxy. If a Type 2 civilization had built this megastructure around the Sun, from Earth we would observe not only strange light fluctuations in that star, but also a powerful emission of infrared light. the body would heat up so much that part of the energy would be lost as heat. If we came across a star with light fluctuations inexplicable by any natural phenomenon that at the same time emits large amounts of infrared radiation, we could deduce the existence of a Dyson sphere, and therefore confirm that someone else is populating the oceans of the universe. Likewise, in even more advanced civilizations, on their way to reaching level 3 on the scale, there would be something else with which to hunt them. Any civilization that was conquering the stars of the galaxy would need to travel at speeds very close to that of light. And a hypothetical ship capable of doing so, when braking in the middle of space, would leave behind an immense trail of ionized gas, a glowing trace that would paint the firmament like a brushstroke of light on a dark canvas. Finally, as the last frontier on the Kardashev scale, a Type 3 civilization that has conquered its entire island of light could in theory make an entire galaxy go dark. With power over all the stars, they could have consumed them one by one, snatch away the last light of a galaxy to colonize another, like parasites sucking the life from the gods of light. However, despite all of this, despite all the trails we've followed, all the efforts made for over 6 decades observing and listening to the skies, we have found nothing. Just a sad collection of false alarms. No one is calling. No one is signaling their presence. All we have is an unsettling calm that astronomers have baptized as the Great Silence.
Esta aparente contradicción entre las supuestamente altas probabilidades de que existan otras civilizaciones extraterrestres y la ausencia de evidencia de las mismas es lo que fue bautizado como la paradoja de Fermi, una incongruencia entre el optimismo de los números y el pesimismo de la observación.
Posited in honor of Enrico Fermi and the question he posed on that summer morning in 1950, the paradox highlights that relying on statistics and estimates indicating that there should be many intelligent civilizations in the observable universe, it's strange that we have yet to find evidence of extraterrestrial life. The Milky Way is an island of light formed by what could potentially be more than 400 billion stars, nearly all of them with worlds orbiting around them. And our galaxy is just one of the 2 trillion that could sail the ocean of the observable universe. Given this unimaginable number of stars, there would have to be an equally inconceivable number of habitable planets, where the seed of life could have found a place to germinate. And if we add to this the age of the cosmos, with galaxies being almost as old as time itself and having had billions of years to flourish, it seems unthinkable that intelligent life has not arisen elsewhere. It is on these premises that Fermi's paradox rests, a term that, since its conception in 1975 in an article written by American astrophysicist Michael Hart, has only increased in fame. The constant failures, the inability to find signs of life out there despite being increasingly able to listen and observe better, have made the concept one of the most recognized in the world of science. With that growing recognition, astronomers worldwide have spent decades trying to find a solution to this problem, to resolve Fermi's paradox and understand why we are surrounded by an unsettling silence that extends through the darkness of space and time. One possibility is that we are simply too primitive to attract anyone's attention. That a civilization advanced enough on the Kardashev scale sees us as mere insects. Infra-evolved beings not worth communicating with, let alone crossing the deserts of the universe to reach us. Another hypothesis that seeks to resolve the paradox is that any civilization, in its aspirations to grow and prosper, becomes its own executioner. That there is a kind of barrier preventing a civilization from developing enough to contact others or travel between stars before self-destructing. A vision that establishes that each and every one of the possible life forms that have arisen have not contacted us or visited us because before reaching that evolutionary point, They have self-annihilated due to their lust for power, victims of their own technology. This is what is known as the Great Filter Theory. A hypothesis that posits that something must reduce the likelihood of inanimate matter germinating life, or, in its most recognized sense, that it escalates on the Kardashev scale. In the context of Fermi's paradox, the Great Filter tells us that intelligence is the curse of life, that which condemns us to extinction. However, far from this pessimism, there are those who argue that we simply have not listened or observed enough, that with our limited reach capabilities, asserting that Earth is the only haven for intelligence would be like filling a tiny bottle of seawater, seeing that it is empty and declaring that there is nothing alive in the oceans. We have to look further and above all for longer. Likewise, it is possible that we are not even looking for what we should be seeking. So far, while there have been minority efforts to capture the echoes of technologies like a Dyson sphere or a light trail caused by interstellar travel, everything related to communications has focused on radio waves. But once again, we are assuming that such an advanced civilization, so socially and technologically evolved, would still be anchored in something so archaic. They could communicate in very different ways, leaving us in the dark, chasing shadows. Advanced beings could be using ghostly particles for their transmissions. Neutrinos, the most mysterious particles of the Standard Model, could be the basis of their communications. Neutrinos are neutral particles without electric charge and even smaller in size than electrons, which interact with matter in an extremely elusive way. Every second, every surface of our body equivalent to a thumb is traversed by 60 billion neutrinos coming from the Sun and other places in the universe without us feeling anything. These entities move through space like ghosts. However, in 2012, a team of scientists from Cornell University demonstrated that communication based on neutrinos was physically possible, as they showed by sending a very simple message encoded in them a distance of 1,000 kilometers and even, most promisingly, through 240 meters of solid rock. A sufficiently advanced civilization could be using neutrinos to send complex messages at the speed of light and overcoming any obstacle thanks to their ability to pass through matter. But with sufficient technology, they could do something even greater. They could use space-time itself as a communication system. They could convert gravitational waves into messages to transmit throughout the universe. If they were capable of manipulating celestial bodies with great gravitational power, they could create disturbances in the space-time fabric. They could create gravitational waves that travel through the oceans of the cosmos in all directions and at the speed of light. An absolute power over the factory of space and time. A manipulation of the foundations of reality. However, perhaps the most unsettling answer to the Fermi paradox is the possibility that we are indeed alone. That the universe has only found in us that way of understanding itself. Reviewing the history of Earth, we can see how it took almost 4 billion years for primitive cells to evolve into the dawn of human civilization. A third of the age of the universe was spent for intelligence to emerge as we know it. An eternity in which the chain of life has not been broken at any point. Billions of years of fortunate stability, far from the chaos and violence of the cosmos, for us to arrive. A collection of atoms as ancient as time itself with the ability to think. Perhaps there are not many worlds where life has found such prolonged balance over time. Maybe we are the only refuge of consciousness in an eternal ocean of unconsciousness. Furthermore, recent research indicates that statistically, intelligent life was more probable 4 billion years ago, and closer to the core of the Milky Way. It could be that we are in the wrong time and place. Too far in space and time from what may have been the golden age of intelligence in our galaxy.
Tal vez hace mucho tiempo la Vía Láctea fue hogar de cientos o miles de civilizaciones, todas ya extintas en el momento en el que nosotros alzamos la mirada al cielo, rodeados de lo que hoy no es más que un cementerio cósmico. Pero también existe la posibilidad de que sigan vivas y hayan decidido permanecer invisibles.
Patrolling the deepest corners of the Milky Way in search of evidence of worlds beyond the solar system, the Kepler Space Observatory has become the most celebrated exoplanet hunter in history. Throughout its mission, which began in 2009, it has observed more than 530,000 stars and discovered a total of 2,778 planets. With the primary goal of finding Earth-like worlds, Kepler's findings fueled all hopes. Its results, scaled to the size of the galaxy, showed that the Milky Way could contain 20 billion planets similar to ours, rocky worlds in the habitable zone of their sun, with the right temperature to harbor water, the fundamental ingredient for life to thrive. This discovery further strengthened the Fermi paradox. Our galaxy is home to an inconceivable number of worlds like ours, where evolution could lead to the emergence of intelligent civilizations. But still we see nothing. We hear nothing. An eternal silence. The overwhelming findings of the Kepler telescope opened the door to a solution to the paradox that until then was considered something out of science fiction. A theory conceived in 2008 by the Chinese writer Liu Cixin that begins to resonate in the astronomical community and was baptized as the Dark Forest hypothesis. In his novel, The Dark Forest, the writer delves into the nature of the Drake equation, into the sociological parameters of civilizations, to present three key axioms, three postulates that together provide an answer to the Fermi paradox. Firstly, we assume that the observable universe is inhabited by an immense number of intelligent civilizations, that although the fraction of planets where life, multicellular beings, and eventually intelligence germinate is minuscule, given the size of the cosmos, there are many civilizations coexisting in that cosmic society. Secondly, we assume that the primary need of any civilization is survival, the protection of its integrity, the search for the security of its members, in the same way that human communities have remained united to guarantee their lives. And thirdly, we assume that civilizations continually expand over time, but that the total matter of the universe remains constant. They increasingly extend their domains into an ocean in which sooner or later they will encounter others who share their same desires and needs. With the three premises combined, the only logical conclusion is that any form of intelligent life will face all others in a struggle for survival on a galactic scale. And in that Cold War, every civilization will recognize contact as something too dangerous.
De esta forma, la teoría del bosque oscuro afirma que las civilizaciones permanecen calladas, sin revelar su existencia, por miedo a ser descubiertas por otras más avanzadas y poderosas. Una hipótesis que resolvía la paradoja de Fermi, diciendo que las civilizaciones verdaderamente inteligentes saben que deben esconderse, porque cada una es un cazador al acecho, en una noche sin luna.
Outside of the literary context, and as an astronomical hypothesis, the theory makes us imagine the universe as a forest in which all civilizations are hunters moving through the darkness. In our home, all forms of life seek to survive, feed, reproduce, and obtain the resources necessary for it. And in that struggle for survival, their greatest and only obstacle is other organisms that share that same goal. It was precisely this competitiveness among species that drove natural selection, which at some point in that ancestral history led to the emergence of consciousness, of human beings, an intelligence that allowed technological progress while maintaining the most primitive needs of life. In unity we find strength, and the first civilizations of the world arose. Cultures poisoned by those desires for dominance that fought among themselves for control of the lands. Looking at our past and our present, it is clear that intelligence has made us both powerful and dangerous. Humans have dominated the planet, subjugating anything that stood in our way. A history that has built today's society, but that will continue to be written. In that future chapter where we look to the stars, an opportunity to extend our empire. But when that moment comes, perhaps we will encounter others who have the same ideas as us. The struggle for survival could extend to the sky when we embark on that journey through the dark forest where other hunters may be lying in wait. And if one of them has an advantage of hundreds, thousands, or even millions of years, contact could result in a massacre. In that forest, there is no fair war. Only annihilation of the weaker hunter. But never knowing if one is the predator or the prey, if every civilization is a potential threat to all others, there is only one strategy for survival. Maintain silence. Do not reveal their existence. Remain quiet, without lighting any torch in the middle of that forest. In that game, revealing their location is a death sentence, because there will always be someone stronger waiting. We have not found intelligent life because any civilization intelligent enough has hidden in the darkness of the cosmic forest.
En esencia, lo que nos dice es que solo existirían dos tipos de civilizaciones, las silenciosas y las muertas, extintas después de rebelarse ante una más poderosa que ellas, porque en la incertidumbre de los contactos incapaces de comunicarse, es comer o ser comido, algo que nos obliga a reflexionar acerca de lo que nosotros mismos estamos haciendo en este bosque.
Our first radio transmissions have already traveled 100 light years in all directions, reaching about 75 star systems, some of which include potentially habitable planets. And although those signals may now be mere noise, someone might be listening to them. Similarly, in 2018, both Voyager probes had already passed beyond the heliopause, the point where the solar wind meets the interstellar medium, turning the two sisters, carrying a part of humanity with them, into ships sailing the ocean between the stars for all eternity. We have long lit a torch in the midst of the darkness of the forest. And there will come a time when we will not only do that. Sooner or later, we will look up to the sky and begin to move through the mist, without knowing if there is another hunter lurking among the trees. The uncertainty will always be there. Perhaps we will never know if we are alone in that forest or if everyone around us is hiding, afraid of our movements. But if we stop looking up there, if we hide in the darkness and we really are the first, the universe itself will have missed a unique opportunity.
Si estamos escribiendo el primer capítulo en esta historia, tenemos que mantener vivo el fuego, asegurarnos de que esa antorcha en lo que muy probablemente sea un futuro cercano, nos guíe entre la oscuridad de ese bosque.